All right, I'm pretty sure some of you are still sobbing in your sleeve over yesterday's crazy long video on trig equation solving and all the different kinds we did. So we're going to take a break from equation solving today. I might show you a couple on the video, but you don't have any in your homework. Because we're going to talk about a bunch of formulas that are on your trig trade sheet. I think you're going to like this lesson because these are just find the formula and substitute some values in, okay? They are the half and double angle and sum and difference formulas. These are on your reference sheet. The first ones we're going to talk about are called sum identities and difference identities. I think on your reference sheet they look like this down here, which is nicer. They have A's and B's instead of alphas and betas, like the book would have. Now, why we have to learn these, it used to be that without a calculator, you could only find and evaluate certain functions by adding and combining different values. So I'm going to show you a crazy one, okay? You don't have to do these, but this is what we used to have to do. When you had 375, you would say, well, that's 330 and another 45. So I would have to go to my sheet and find this crazy formula that says you take the cosine of alpha plus beta here and here, and you substitute these values in. So it would say the cosine of 330 times the cosine of 45 minus the sine of 330 times the sine of 45 is going to give me the exact cosine of 375 degrees. Then you would substitute in values, okay? So you grab your unit circle and you go to the cosine at 330, which I'm thinking is square root of 3 over 2. The cosine at 45, which I'm very sure is square root of 2 over 2. The sine at 330 is negative 1/2. And the sine at positive 45 is square root of 2 over 2. So when I simplify this, I get the square root of 6 over 4 minus negative, which is plus positive. 1 times square root of 2 is square root of 2. 2 times 2 is 4 in the denominator. So my answer is square root of 6 plus square root of 2 all over 4 is the exact cosine of is the exact value of the cosine of 375. Aren't you glad we don't have to do those anymore? Just type it in your calculator and it's exact enough, right? So that's why these were originally useful, but we are just going to do something really easy with them. We're going to look for these values and trade them in, okay? So tan plus tan over 1 minus tan times tan. We're going to look for that formula, and it's right down here. It says this is really the tangent of A plus B, where A is 48 degrees and B is 102 degrees. So you have the tangent, let's see, 48 and 102 is 150 degrees. So then you can go to your unit circle to 150 degrees and the tangent is y over x, so you get 1 over negative square root of 3 or negative square root of 3 over 3. Okay? So all we did was substitute into the formula and then we went to the unit circle. And that's when it says to do, then find its exact value. Some of them we don't even have to do that last step. All right, this one is cosine times cosine minus sine times sine. So I go down here and I find cosine times cosine minus sine times sine right here. Okay, and I say this becomes the cosine of A plus B, which is 300 plus 15. So it is the cosine of 315. And if you go to your unit circle, the cosine of 315 right down here is square root of 2 over 2. Easy peasy, huh? All right, so a couple more here. Let's Still in degrees for this one. This one says sine times cosine plus cosine times sine. Sine times cosine plus cosine times sine is this guy right here. So it's the sine of a plus b, where a is 20 degrees and b is 10 degrees. So we get the sine of 30 degrees, which if we go to our unit circle, the sine at 30 degrees is the y value is 1/2. And we're golden. Okay, this one has tangents. We have a plus on the top and a minus on the bottom. So we've got to find that one. Plus on the top and a minus on the bottom is this one, tan A plus B. Uh-oh, we're in radians, but we can do this. Tan A plus B. But it's the tangent of pi over 9 plus 5 pi over 36. Now we could get a common denominator here. This would be 436, and we'd get 936, which is 1/4, I believe. But we could also cheat. If you go to the home screen on your calculator, this is 1/9 of a pi plus 5/36 of a pi. And that's 1/4 of a pi. Okay? So we end up with the tangent of pi over 4. And the ordered pair at pi over 4 is square root of 2 over 2, comma square root of 2 over 2. So y over x is 1. All right, so this whole mess up here simplified down to a 1. All right, we're going to play around with these a little bit more. The first one says don't evaluate these because they're not going to come out unit circle ones. So cosine, cosine minus sine, sine is cosine, cosine minus sine, sine is cosine of alpha plus beta, or 73 plus 21, which is the cosine of 94 degrees, and you're done. This one is cosine, cosine minus, I'm sorry, sine, cosine minus cosine, sine. Okay, sine, cosine minus cosine, sine is sine of alpha minus beta, or a minus b. So it is the sine of the a minus the b. This is a, this is b. We're done. Can't do anything with that. Okay? You liking these yet? Sine, cosine minus cosine, sine. Sine, cosine minus cosine, sine is this one. So we have the sine of a minus b, which is an alpha. This is actually on your sheet, I believe. I don't know if I included it. I think that is a cofunction identity. If you look on your sheet under your cofunctions, it says sine of alpha, or pi over 2 minus something is actually the cosine of the angle as well. Now I can show you why that's true. The sine at pi over 2 has a value. The sine at pi over 2 is 1. So we could have traded that for a 1 times the cosine. And the cosine at pi over 2 is 0. So you'd have had 0 times the sine. And then this would be 0, so you would have ended up with only the cosine. So either of these are okay with me. All right. Tangent minus tangent over 1 plus tangent is this guy. So we have the tangent of alpha minus beta, which is y minus pi over 8. And that's not anywhere on my unit circle or my sheet, so I'm done. All right. I did not assign these. I should, because they're so easy. But what you have to do these is expand these out using these functions and then put in the values. These are the easiest proofs ever. So if you had sine of, and we'll use an a and a b here. So you'd go down here and it's a difference. So it says you take the sine of the first one times the cosine of the second one minus, okay, over here, cosine of the first one, which was pi, times the sine of the second one, which was x. All right, then you plug in off the unit circle those values. Well, if you go over to pi, the sine is 0, and the cosine is -1. So this all becomes 0, minus a -1 becomes 1 sine x, which is equal to the right-hand side up here, sine x. So we just did a proof. Okay. I'll do one more just because they're fun, but again, not on a quiz. I just want a different color here. Okay. So this one says sine 270 plus theta. That would be this one. So you'd have the sine of 270 times the cosine of theta plus the cosine of 270 times the sine of theta. Okay, the ordered pair down at 270 is 0, -1. So you'd have -1 times the cosine plus 0 times the sine, which would be negative cosine, which is this right-hand side up above. Easiest proofs ever. Love them. Okay. All right, this is just for exposure as well. Please don't fast forward through this because I want to show you, but these are equation solvings, but you would use these values up here. Okay, so we're using this one and then this one because we have the sine with an add and a cosine with an add. So I'm going to expand all this out using the first one. Sine pi over 2 cosine of x plus cosine pi over 2 sine of x. And then I'll switch colors here. This one is this guy. So I have plus the cosine of pi over 2 times the cosine of x minus the sine of pi over 2 times the sine of sine of x, and that's all supposed to equal 0. Well, when I plug in values from the unit circle, okay, pi over 2 has an ordered pair of 0, 1, so the sine is 1, but the cosine is 0. Oops, the sine is 1. Did I do something wrong? Let's see. This one was sine, cosine plus cosine, sine, and this one was cosine, cosine minus sine, sine. Okay. So these are both 0, and I end up with the cosine of x minus the sine of x equals 0, or the cosine of x equals the sine of x, which happens at pi over 4 and 7 pi over 4. Okay. I'm kind of concerned if I got that right. This is wrong. This is 5 pi over 4, but otherwise I did it right. All right. You know what? There's one more of these in your notes, and I'm going to skip it because they're not on the, okay? I'm not going to take time. I wanted to make this a short video. Okay. We still got double angles to do. I could have stopped the video, but I'm going to keep going because these are easy too. All right. So we have double angles and half angles. These use some crazy formulas again. These are super important. According to Gupta, you got to memorize this one and these. Okay? The half angles, not so much. We're going to look at them and just use the reference sheet, but these are the ones that you need to memorize. Okay? Especially this one, she says. Sine of 2x or 2 theta is 2 times the sine times the cosine. All right. So we are going to use, that's what they look like on your sheet. We're going to use these to make some trades. So cosine squared minus sine squared. If I go back here, cosine squared minus sine squared is a cosine of 2 thetas. Well, a cosine of 2 11 degrees would be a cosine of 22 degrees. That's it. This one says 2 times sine times cosine. If I go back here, 2 times sine times cosine is the sine of 2 of those angles. So this is the sine of 2 thetas, which are pi over 5s. So we get the sine of 2 pi over 5. We're just looking to trade things out from that list. So this one has 2 tangent of 3a's over 1 minus tangent squared of 3a's. I don't think the 3 matters. Here we go. 2 tangent over 1 minus tangent squared is simply the tangent of 2 of those. So this is the tangent of 2 3a's, which would be the tangent of 6a. Okay, 2 cosine squared minus 1. Right here. Guys, 2 cosine squared minus 1 is a cosine of 2 theta. So this is a cosine of 2 times the angle, which is 3 pi over 7. So we get the cosine of 6 pi over 7. 1 minus 2 sine squared of 55. It's kind of scrunched in there. But 1 minus 2 sine squared is also a cosine of 2 theta. In case you didn't figure that out the first time, all of these are substitutions for cosine of 2 theta. So you could do any of those, and we'll talk about why we would pick one over another when we do more equation solving tomorrow. 1 minus 2 sine squared was a cosine, whoop, can't make an S, of 2 55s, or the cosine of 110. All right, sine over 1 plus cosine. Sine over 1 plus cosine is this guy, tangent theta divided by 2. So this would be tangent of 8x divided by 2, which would be the tangent of 4x. Okay, this is just using a reference sheet to trade these out. But we're going to do a few. These are my favorite, where we have to draw. And this is going to be on a test or quiz, so please pay close attention. All right, it says we have an angle between 0 and 90, so we're in the first quadrant. It says the sine is 1/4. So if I draw a bow tie triangle and I label opposite over hypotenuse, now I'm supposed to find the sine of 2 theta. The trade for that is 2 times the sine times the cosine. Well, I know the 2, I know the sine, but I got to figure out what the cosine would be by completing this picture. So x squared plus 1 squared equals 4 squared. This is 16, so I get 15. So x is the square root of 15. So the cosine is the square root of 15 over 4 because it's adjacent over hypotenuse. So you can put the 2 on top. So I have 2 times 1 times square root of 15. Denominator is 1 times 4 times 4. And then the 2 and 16 reduce, so I get the square root of 15 over 8. Okay, kind of crazy, but you can find these exact values. That was just that one done for you already. So we're going to practice. But we got to think carefully about quadrants. This is very important. It's telling you that somewhere between 180 and 270 is where this angle lies, which means it is in quadrant 3, which means the bow tie triangle looks like this. The tangent is 4/3, opposite over adjacent. But, careful, in quadrant 3, you went left and you went down. So those are both negative. Now when you do Pythagorean theorem, -3 squared plus -4 squared equals the hypotenuse squared. You get 5, and that's always positive. Okay? The radius or the hypotenuse is always positive. Okay, so now we have 3 values to find. This is the only one that asks you to do all 3. But sine is 2 times a sine times a cosine from right up here. So I have 2 times the sine of this triangle, which is -4/5, times the cosine, which is -3/5. So 2 times -4 times -3 is +24. And in the denominator, 1 times 5 is 25. So the sine of 2 theta is 24 over 25. All right, then I have cosine 2 theta. I could use any of these. I'm just going to use the first one. It's cosine squared minus sine squared. So if I go over here, the cosine is -3/5. And I'm going to square it. The sine squared is -4/5. And I'm going to square it. So I get 9 over 25 minus 16 over 25. Okay. And that, because you square and it becomes positive, and then it's still minus in here, make sure you're good on that. That becomes -7 over 25 because it already has a common denominator. So that is the cosine of 2 theta. Has that exact value. And then we have tangent. And there's a couple ways you could do tangent. There's actually a shortcut. I can explain it quick right now. Tangent, remember, is just sine over cosine. So you could do, since we're all of these are 2 thetas, it's going to come out sine over cosine, which is 24 over -7. But I'm going to go ahead and do the formula. The formula here for 2 theta is 2 times the tangent times divided by 1 minus tangent squared. I'm going to use our calculator here, but it's 2 times the tangent, which was 4/3, divided by 1 minus 4/3 squared. Okay, that gives us 8/3 on the top. It is, this denominator is 1 minus 16/9, which is, I'm not going to use my calculator, you can use a calculator. 9/9 minus 16/9 would be -7/9. That was, I didn't flip it over yet, so that's still divide. So I get 8/3 times 9 over -7. 3 goes into 9 3 times, which is 24 over -7. All right, could use calculator. Way back here, if you had typed this into your calculator with extra parentheses here and here, and then done a math enter, you would have got -24 over 7. All right, no more icky ones like that. These are all shorter and sweeter because they only ask you to find one thing. All right, pi over 2 and pi. Pi over 2 and pi means we are in quadrant 2. If the tangent is negative square root of 3 over 1. All right, sorry about that. Tangent is opposite over adjacent. Now, in this quadrant, you went left, so that's negative, and the square root of 3 is positive. Then if we do Pythagorean theorem, either r or hypotenuse, whatever you want to call that, this is 3, this is 1, r squared is 4, square root of that, and you get 2. All right, this is also a 30, 60, 90 triangle, but cosine of 2 theta, okay, is, I'm going to use the first one again, cosine squared minus sine squared. So the cosine here is adjacent over hypotenuse, and the sine is opposite over hypotenuse. So square this guy and we get 1/4. Square this and the top becomes 3 and the bottom becomes 4. And we subtract and we get -2/4 or -1/2. Now, this is one we actually could have figured out using the unit circle. I just want to show you. The tangent is -square root of 3. I think I have a unit circle somewhere, don't I? Here we go. The tangent in this quadrant is -square root of 3, right here. So that is a 120-degree angle, and we are trying to find tangent of 2 times that would be 240. Okay, the tangent at 240. Okay, did I just mess up? Cosine of 2, we're not doing tangent, okay. So we want the cosine of 2 theta, okay? Cosine of 2 theta, that's what I'm trying to find. So when I go back here, we had 120, but we're trying to find the cosine of that, which would be the cosine of 240. And the cosine of 240 is -1/2, which I sure hope is what we got at the end of this problem. Yep. Okay, the cosine of twice that angle was -1/2. Most of them aren't unit circle triangles, so it won't help us. All right, do I have 2 more? Yes, 2 more. This one is between 3 pi over 2 and 2 pi, so we are in this quadrant, quadrant 4. The sine is opposite over hypotenuse. This would be negative because we went down, and when we do Pythagorean theorem, this is going to be subtracting 12 squared, and you get 25, and x is 5, okay? And now we're supposed to find the tangent of theta over 2, so we have to pick one or the other of these. I think I'm just going to use the top one. So we would have 1 minus the cosine over the sine. So we have 1 minus the cosine right here is adjacent over hypotenuse, divided by the sine, which is opposite, that's a 2, over the hypotenuse. Okay, if we make this 13/13 minus 5/13, we get 8/13 is divided by -12/13. You can use your calculator, but it's 8/13 times the reciprocal. These will divide out. 8 over 12 reduces by 4 to 2 and 3. If you use your calculator, maybe I'll just show you on your calculator real fast. It's was parenthesis 1 minus 5/13, all divided by -12/13. What did I do wrong? I think I need parentheses around the denominator. Insert a parenthesis. Math, enter, enter, was negative 2/3. Okay. Last one. Tangent is 4/3. This tells me we are between pi and 3 pi over 2, so we're in quadrant 3. The tangent is 4/3 means opposite over adjacent from here, but these are both negative because we went left and down. If you do Pythagorean theorem, that turns out 5. We're trying to find cosine theta over 2, okay? This is the only one of these I'm going to do. It has a plus or minus here, and you have to determine whether it's plus or minus. The value at the end, okay, is based on where this angle is cut in half. So if I'm going to talk about it in degrees. If my angle is somewhere between 180 and 290, 270, just kidding, I'm supposed to cut it in half. When you cut this in half, you would have somewhere between 90 and 135, because remember this was a 7. So the cosine of an angle that winds up between 90 and 135 in quadrant 2, the cosine is negative. So we have to remember at the end of this problem it's going to be negative, not plus or minus. Because we had to take these restrictions, we're in quadrant 3, and cut them in half, and that landed us in quadrant 2 where the cosine is negative. All right, so I'm going to have negative square root of 1 plus cosine over 2. In this particular triangle, the cosine is adjacent over hypotenuse, which is negative 3/5. And we want an exact answer, so we can't square root it on the calculator, but you could do this calculation on the calculator. Maybe I will. Just to show you one more on the calculator. I'd rather do it by hand, but okay, on the top we have 1 plus negative 3/5. And then it's all divided by 2. Math, enter, enter, because I want a fraction, and I get 1/5. Okay, I have negative square root of 1 over square root of 5, which is 1 over the square root of 5, which I rationalize. And I get negative square root of 5 over 5. All right, again, it had to be negative. You have to choose that by figuring out the quadrant and the angles, and then cutting them in half because it said theta over 2, and determining what the sign would be there. Not on a test or quiz. Okay. That was the double and half angle stuff. Mostly fun.